All right, guys, so if we take a look at our packet from yesterday and we look at the section that says let's practice, today I just want to do a couple of these, just kind of refreshing on the multiplication stuff we did yesterday with absolute value, and try graphing these without having to make those giant tables. And then I do want to move on today and do a couple things with some adding and subtracting, and then get you some time to practice. That's my goal. I want to try to keep kind of the lesson piece short and sweet today, and get you some more time to practice all the things we've looked at the last couple days. So let's take a look. Let's just start off with question number 1. Let's take a look at question 1 on the let's practice part. And I just have a few kind of little prompts under there just to help you think about the things that we did last class. So the first question I have for you is, we're multiplying by 4. And if you need to, you can look right up above. We took the notes on what all the different things mean. So we have, first question is, do we have a stretch or do we have a shrink? We're multiplying by a number that's bigger than 1. Is that going to stretch my graph and make it skinnier? Or is it going to flatten my graph out? It's going to stretch it. Number bigger than 1 is going to stretch. Number bigger than 1 is going to stretch. I want to try to work some of that vocab in for us. Again, just something that I really want to introduce us to this year, and then in future years it'll be kind of more of a given for you. And then reflection. Reflection means, is it going to flip upside down? Yes or no? What do you think? No. Why won't this one reflect? What do we need to have a reflection? We need a negative sign to have a reflection. Awesome. And then, last but not least, before we graph, what's the slope of our right side of our V going to be? Slope of the right side of the V is going to be 4. Now, if we want to, we can make some little notes here. Since it is the right side, when we make our movements, we have to make sure we're staying on the right. So for a positive 4, we're going to go up 4, and we're going to go right 1. Did we move our graph at all yesterday? Did we go left or right or up and down yesterday at all? No. Anytime we graphed yesterday, where was that vertex point or kind of that middle point on our graph? It was always at 0, 0. We didn't move our graph around at all yesterday. It was always right at 0, 0. So we're going to start there. And then we have the slope of our right side. The slope of our right side says we need to move up 4. 1, 2, 3, 4. And we need to move right 1. I can't go up 4 and right 1 again. I run out of graph, and that's okay.
You go down.
So then to get the other side of our graph, we have a couple options. We can always draw in that imaginary line, that axis of symmetry. I think this is the easiest way to do it myself. I know the slope of the right side, so I use the slope to get the right side of the graph. And then I use that symmetric property to get the other points. Right now, this point right here is 1 away from the middle. It's 1 box away from that middle line. So I'm going to have a point on the other side of that line that's just 1 box away. Its mirror image is right there. Now, if you don't like doing that, I think that's the easiest way to get the other side of the graph. If you don't like doing that, you can find the slope of the left side. Slope of the left is going to be negative 4. If the slope of the right's positive 4, the slope on the left will be negative 4, just opposite signs. But the catch with this is we have to make sure we stay on the left side. So we're going to have to go up 4 and then left 1. I have to stay on the left side of my graph. So down and right isn't going to work. It's going to make my V open sideways, and we're not doing that. So I think it's easiest, the slope on the right side is going to be that number we're multiplying by. It's going to be our multiplier out front. And then just use your symmetric property to get those mirror images on the other side. I think that's the easiest way to graph these, but that's my personal opinion on that. Okay. Let's take a look at number 2. Number 2, I'm looking at my multiplier here. It's 1/4. So we have a number smaller than 1. Is that going to stretch my graph out, or is it going to shrink it? It's going to shrink it. It's going to flatten it out. It's going to shrink it. Do we have a reflection on this one? No. No negative sign, no reflection. So that means we know our graph's going to open up. And then what would the slope of my right side be? 1/4. Whatever number I'm multiplying by, that's going to be my slope. So, and again, just like earlier, we can write the directions down. We have to stay on the right side. So up 1 and right 4. We have to stay on that right side. We don't move left or right, up or down at all. So we know the middle of our graph is going to be at 0, 0. Today we're going to start moving our graph around, but for right now, if you don't move up, down, left, or right, the middle of that graph, that vertex, is at 0, 0. We go up 1 and right 4. So I've got the right side of my graph. And again, if you want to try to do the left side by using that negative slope, you sure can. I personally think it's easiest to take that point that we know at 4, 1. It's 1, 2, 3, 4 boxes from the middle. So I'm going to go on the left side, 1, 2, 3, 4 boxes from the middle. I think that's the easiest route. But if you want to go with doing the negative slope, you sure can. It's kind of up to you. So when we're just multiplying by a number, that number we're multiplying by, if it's bigger than 1, we're going to stretch. If it's smaller than 1, we're going to shrink. And that number we're multiplying by gives us the slope for the right side of our V shape. So we just graphed these two, not a lot of time, no huge table. Didn't have to do any computation at all. And that's the point I want us to be able to get to with everything that we're going to be doing with these graphs. Now in both of these, we answered for the reflection idea, we answered no. So let's go on to the next page, or the back side of this page, excuse me. And I want to take a look at, number 7. I know, we skipped a whole bunch. I told you we weren't going to do them all today. I want to look at number 7. With number 7, are we going to have a stretch, which means a skinnier graph? Or are we going to have a shrink, which is a flatter graph? We're going to have a shrink. So when I look at my number, it's 2/5. 2/5 is smaller than 1. That's going to shrink my graph. Do we have a reflection on this one? Yes, we do. How do we know that there's a reflection? Yeah, there's a negative. So that means my graph, when I graph this, my graph better look how? What should happen to my V? It is wider. Then what does the reflection part do? It's upside down. So we're going to have, because of the shrink, we have a flatter V, and it should be opening down. It should be upside down. All right, so we said the number 2/5 is going to make it shrink. The negative sign makes it reflect, which means it's going to be upside down. So what's the slope of my right side? -2/5. Here's where we have to be careful, is with the negative slopes. It's for the right side. I have to stay on the right side of my graph. So when I move for my negative slope, I have to go down 2, and then I have to go right 5. I know when we graphed lines, we kept saying for negative slopes, we could go up and left or down and right. But if I go up and left, I'm now on the left side of my graph. So at the negative slopes, you have to be really, really careful. You always have to move down and right in this case. Our graph is not moving left or right, up or down at all. So that means that vertex, that middle point, is still at 0, 0. We're going to go down 2 and right 1, 2, 3, 4, and 5. Again, I think the easier way, and you wouldn't even necessarily have to draw that dashed line in there for the axis of symmetry. You wouldn't have to. It helps me when I'm counting my boxes to know exactly where the middle is. So I'm going to take this point that we know for sure we got from our slope. I'm going to go 1, 2, 3, 4. It's 5 spaces back to the middle. So I'm going to go 1, 2, 3, 4, 5 spaces on the other side. And this graph is doing exactly what we said it would. We said it would be a flattened V, which we definitely have, and it's going to be upside down. Check and check. We got both of those things. Okay? So I just wanted to do a couple of those, and from your responses, guys, it sounds like we're catching on to what that multiplier is going to do. Is it going to stretch it, make it skinnier? Is it going to shrink it, which makes it flatter? Or are we going to flip upside down? That piece seems to be sticking for us. So now what I want to do is I want to go to, I'm going to give you guys a second packet, and don't freak out about it. I've already decided to shorten it from what I made it anyway, because yesterday took a little bit longer. Alright, so if we're looking at our second packet, what I have first off, just that refresher on what the most basic absolute value equation looks like. The most basic one, remember, oops, sorry guys, thought I had my pens there. There we go. The most basic absolute value equation is just y equals plain old absolute value of x. No multiplier, no adding, no subtracting, nothing. So the most basic one, the vertex, that middle point, was always at 0, 0. Our slope on the right was just 1. Reflect our points over, so the other side matches. This was our basic one. Yesterday, and then right away today, we were doing some multiplying. Multiplying made our graph stretch, or get skinnier, or it made our graph shrink, which made it flatter or wider. Multiplying by negative made it flip upside down, but it didn't move it anywhere. That vertex point was stuck at 0, 0. It didn't move it anywhere. It was stuck there. So now let's see what happens. Today, we're going to focus on doing some adding and subtracting inside of those absolute value bars. So first up, I want to see what happens when we add inside our absolute value bars. So if you notice on the end here, I have an x, and then I just put a generic plus h in there. H can be any number we want. So what's going to happen when I add a number inside those bars? Because we don't know what this is going to look like yet, I do have a shifting back to that table piece just for this one today. And we're going to do just one more at the table piece because we don't know what happens. And then as you guys saw this morning, we graphed 3 of them together and we didn't need a table at all, and we made 3 perfect graphs pretty quickly. So stick with me on the tables here, and then we will get to a shortcut for this adding and subtracting piece today too. All right, so first up, we've got a -3 we're going to put in for the x. So we're going to put it into this expression right here. So we have our absolute value bar, -3 for the x, plus 1, and then there's my other absolute value bar. Before we do the absolute value, we have to do the addition inside of those bars first. So we have -3 plus 1 would give me -2. So I still have the absolute value bars there. I have not found the absolute value yet. I have to do whatever's inside those bars first. Absolute value of -2 is 2. Remember, the result of absolute value, it's that distance from 0, so it's always going to be positive. So the first ordered pair I have is -3, 2. Yep, -3, 2. There we go. And if you're feeling comfortable with this computation stuff, guys, if you want to work ahead of me on this table, you're more than welcome to. If you need to stick with me, that's fine. Next up, instead of x, we're going to put a -2 there. We have to do the addition first. We get -1. Absolute value is 1. And again, we had talked yesterday, I mean, fill out as much of the table as you need. Fill out as much of it as you need. If you can jump right to those ordered pairs, that's fine. It's my goal today that this adding and subtracting piece becomes just as quick and easy as that multiplication piece seems to be for us already today. All right, next up is -1 plus 1. We get a 0. Absolute value is 0. -1, 0. So right away, guys, take a look. We are at -1, 0. Means we're not going to get the point 0, 0 this time. I can't have a point at 0, 0. That'd be a funny looking V if I put a point right next to this one. So let's keep rolling with this table and let's see what's going on here, because 0, 0 is not part of our graph. We have a -1, 0. All right, so we have 0 plus 1 gives me a 1. And again, be careful on these. Absolute value is a distance. It doesn't mean I changed the sign. It literally means how far am I from 0, and we are 1 space from 0. So 0, 1. Next up is +1. We end up with 2. So 1, 2. And then my last one, I know you're thinking, Miss Golly, we've got that V already, and you know what, guys? We do. If I end up putting this one in, we get 3. Then we're at 2, 3. Now we've got kind of that weird point there. But I put this one on there. I knew it was going to do this. I wanted to take the opportunity to make the point that if this happens to you, if you try to make a table, and this happens to you where your V looks a little lopsided, use that symmetric property and even it out. Don't draw an uneven V. This one right here should have a point. So let's see, here's the middle of our V. Here's the middle where it changes directions. So we're going down and then up. So where it changes directions. This random point here is 1, 2, 3 from the middle. So on the other side, we're going to have 1, 2, 3 from the middle. So make sure your graph is symmetric. If you need to add in an extra point, add in an extra point. I'm hoping that by the time we're done today and then next class, that we're just using shortcuts all the time to graph these. But the table is always going to be an option for you. You can always sketch out a table if you need to. All right, so what happened with our graph here? What happened with our graph? We see the original one up above. We see the original one up above. That vertex point is at 0, 0. The slope of the right side is 1. How does it shifted over 1? Which way? Yeah. So now the middle of our graph is -1, 0. We went left. It moved left how many? Just one spot. Here's one of the big things I do want us to note. I didn't multiply by anything. Multiplying is the only way to get that slope to change. All we did was add a number inside those bars. So my slope didn't change. Adding that 1, and I want to stress this, because we saw this when we were graphing lines. We did some of these transformations when we graphed lines last trimester. And when we did the addition piece, we graphed it with the lines, and we're seeing it now with absolute value. Addition moved left. When I added a number inside those bars, it went left. We just made the table, and that computation looks great. We didn't make a mistake on the computation, and when we graphed those ordered pairs, our graph moved left. So I'm not just asking you to buy into what I'm telling you. We did it and we saw it. That graph moved left. So now, again, I wanted to try to shorten things up a little bit for you guys today. Go to the back side of this page, and instead of adding 1, what do we think is going to happen when we subtract 1? Okay, we're thinking it's going to go right. Let's try it out. Let's try it out. And like I said, bear with me. We're going to use the table to verify what we think. And then based on our work with the tables and seeing the result, let's create the shortcut. Okay? So here we go. In for x, we're going to go -2. Scoot this over a little bit here. So -2 minus 1. -2 minus 1, we got a -3 there. And again, -3 is 3 spots away from 0. So the ordered pair, we have -2, 3. I don't know why my table's not showing up, but it's kind of coming in piece by piece. So -2, 1, 2, 3. And again, if you're getting more comfortable with the computation, you go ahead and work ahead of me if you'd like. -1, 2. And again, we're just using the table to verify what we have a pretty good feeling of is going to happen. If adding 1 made it go left, I think it's a pretty good guess that subtracting is going to go right. And we saw that when we graphed our lines too. So we have a 1 minus 1, we get a 0. So we have a 1, 0, 1, 0, there it is. So again, we know our graph has been moved because 0, 0, it's not going to happen for this graph. 0, 0 is not going to happen for this graph. So 2 minus 1 is 1. 2, 1, we're starting to go back up. And we have 3, 2. Kind of have that lopsided V going on again. So I'm going to go ahead and draw my line right through that vertex point where my graph changes directions, or where the two sides of the V come together. The pointy part of the V, however you want to describe that. All right, so we are this random point here. We're 1, 2, 3 from the middle. So on the other side, we're going to have 1, 2, 3 from the middle. So now we have our graph evened out. I'm going to go ahead and draw our sides in. What do you guys think? Were we right? Did it go right? Yes, it did. That vertex point, that middle point's no longer at 0, 0 like it was in the original. Now we're at 1, 0. We moved right 1. We moved right 1. Again, just to note that subtracting, it didn't change my slope. So when we added inside the absolute value bars, we moved left. And again, I'm not just telling you that. We made the table of values. We graphed the ordered pairs. We saw it move left. Same with this one. When we subtracted 1 inside the absolute value bars, I'm not just asking you to just trust me on it. We made the graph. We found the ordered pairs. We made the table. We graphed the points. It went to the right. So at the bottom of this sheet, I just want to summarize. I want to do one of the practice ones with you, and I'm going to give you the rest of the time to do the practice, just the rest of the few that are there. Okay? So let's do a little summarizing. Here's all the pieces we have, and yes, I brought that A value back in because I don't want us to forget what we did yesterday, and that piece is going to be there for us as well. The negative sign, we refreshed on that part this morning. The negative sign causes a reflection, or in other words, we go upside down. One of my classes yesterday said it flips. So kind of up to you how you want to describe that negative sign. Technical language, reflection. When we saw it yesterday, we described it as upside down. One of my other classes described it as a flip. I like either way. Any of those things work. Now that actual A value, that actual number piece, remember that's the slope of the right. It's the slope of the right side. Bigger than 1, we stretch, which means our graph is skinnier. Between 0 and 1, that's when we shrink and we get wider, or a lot of my groups are also saying it gets flatter. So that A value, that's a really important thing. It tells us a lot about our graph. It gives us our slope, tells us if our graph should be skinnier or if it should be wider, or if it should be flatter, however you like to describe that. So that A value does a lot for us. Now the subtracting or adding inside those inside those absolute value bars, not parentheses, absolute value bars. These two, they work together. They work together. So when we had plus h, which way did we go when it was a plus? Which way did we move or shift? When we did the plus 1, which way did it go? Take a peek on the front side of your sheet if you need to. Which way did it go with the plus 1? Right. Take a look on your sheet if you need to. Let's not guess. We did it. Let's verify it. It moved left, yeah. So remember from our work with graphing lines at the end of last trimester, that plus, I know in our brain, plus is positive, it should be going right, but we're going to move left. If you have an x minus a number, it moves opposite of what we think it should. A minus sign, we think that's negative. The negatives are over on the left. But it actually moves right. We saw it today. We saw those two things happen. It's not just you're taking my word for it, I'm throwing this at you. You guys made the table, you guys graphed it, you saw it move those ways. So now when you move on to the practice piece, it is on its own separate sheet. So if you need to rip those two apart so you can be looking at this while you're doing the practice, it's not a bad idea. I do want to do just the first practice one with you to show you how you can use those shortcuts to make graphing simple without having to make a whole huge table. Because the tables can be very time consuming. We can very easily make some computation errors with absolute value. So let's do the first one together, then I'm going to give you the rest of the time to try out the last few that are left. So here we go. Let's work our way through this. The first thing I come across is I'm multiplying by 4. Multiplying by 4. It's going to tell me that my graph stretches. Or if you want to just circle it, you can. It's going to tell me my graph stretches. What else does the 4 tell me? We can fill in whatever lines we want to. Are we going to have a reflection? Nope, because there's no negative sign. And then that 4 also gives me that slope on my right side. Up 4, right 1. We've got to go to the right. We're on the right side of the graph, slope of the right. So again, that multiplier piece, that number in front of the absolute value bars, it tells us a ton about our graph. It tells us if it's going to stretch or shrink. So should it be skinny or wide? It's going to tell us whether or not it reflects. So is it going to open up or is it going to be upside down? And it also gives us the slope to the right side of our graph. So that multiplier piece is huge for us. And then that -1, we're subtracting 1. And like I said, if you need to, guys, rip these two sheets apart so you can see that summary piece that we just did. Don't just automatically go with, oh, well, it's a minus, so I think it should go this way. Take a look at the pieces that we just did. Want to make sure we practice this right. Otherwise, however we practice it, it's going to be really hard to change it if we practice it wrong. So when we're subtracting, which way do we go? Which way does subtracting go? It goes right. We're going to go right 1. Now I know I'm labeling some of those things right up on the equation, and then I'm filling in those lines that I have for you. I wanted to label it on the equation so you know when you look back down at those lines we filled in, so you know which part, what did the 4 tell me, and what did the -1 tell me. All right, so that -1 though, even though it doesn't give us as much information as that 4 does, the -1 is super important because it tells us where that vertex point is. It tells us where to find the middle. And it tells us that the middle is to the right 1. It tells us that the middle is to the right 1. So that left-right piece is super important because that tells us where to start our graph. Without that starting point, the slope doesn't mean anything. The reflection doesn't mean anything. All right, so from that point, now we use our slope. Up 4, 1, 2, 3, 4, and right 1. To get our other point, I like drawing that imaginary line right down the middle and using that symmetric property. So the point that we have right here is 1 box away from the middle. So there's going to be 1 on the other side, 1 box away from the middle. And I'm sure as you get more practice with this, you're going to find your own little shortcuts for these. I'm sure you will. If you'd like to draw arrows like I did to say, hey, the 4 is going to stretch or the 1's going to go right, I have all those different blanks for you to fill in just to make sure those are all the things you're thinking about. Okay, so just so you don't miss something, that's why I have all those kind of those little prompts there, those little blanks for you, those little questions. Okay, so the rest of the time today is yours. There's not a ton of problems left. If you've really caught on to this, you'll probably knock this out in about 5-10 minutes. If you're struggling with Miss Scally, I'm not sure really where you're getting that slope piece at or why it's moving right, things like that. Now's a great time for you to ask. So the time is yours. If you need me to check something for you, I sure can.